Okay, everybody. Hope everyone's all caffeinated up. Your blood's flowing after that morning stretch. I feel good. I hope everyone feels good. I'm going to ask the panelists for panel 2 to come up. That is Mike Brown, Frank Perry, Henry Liu, Monica Kim, and Suzanne Sloane. Come on up to the stage. So we have this panel, and then we will have Dr. Bogdan Epureanu as our morning keynote speaker. And then we'll be moving to lunch, and lunch will be here. So stay tuned. The best is yet to come. So before we get started, I would like to introduce Mike Brown with the Southwest Research Institute. Mike is an OmniAir board member, longstanding, and is the chair of our coordinating council. The coordinating council has representation from each of the 10 working groups and sub-working groups and directs the technical work of OmniAir's various committees. Mike also has been very active in the testing and development of the testing and certification program originating from a Federal Highway Administration contract back in 2016 and 17. And it's through much of Mike's work and dedication, along with Dmitry Kizhniak and some others in the room and DanLaw representatives, that we actually have a certification program today. And I can think of no better person to lead this great discussion of these distinguished panelists on the future of testing in connected vehicles. Mr. Brown, the floor is yours, sir.
All right, thank you, Jason. Good morning, everyone. Hello, I'm fascinated to be here. It's absolutely awesome. I love seeing the Plug Fest audience, the energy. Burkenda got us going with a nice morning stretch. One of the things I always love about the Plug Fest, though, is this is a wonderful event to actually see, like, what are the issues, what are the interoperability things we still got to work through, but actually see a lot of it work. Rather than just talk about it, we'll get to see it work. And it's great to see the teams at work kind of working through issues, making sure everything's interoperable, and I'm really looking forward to the demonstrations and the tours this afternoon. And I'm also really looking forward to this panel. Part of my role as the coordinating council chair is to help organize our working groups and make sure we're always looking at things that we need to do in the near term, but also the long term things we should be keeping an eye on. And so it's a somewhat selfish opportunity for me to get such a wonderful brain trust up here and pick their brain, and then also let them be interactive with you all so that we can start to look at things we should do in the next year or two, but also things down the road that OmniAir should be doing as part of our work program. I'll just briefly kind of mention who's on the panel, and then I'm going to give them each a few minutes to introduce themselves, their organizations, and what they're doing into V2X testing. We have a wonderful panel with us today. We have Suzanne Sloane, who's the Technology Policy Advisor for the U.S. Department of Transportation. We have Monica Kim, who's Global Business Development Lead for Saesol Tech. Frank Perry, who's Senior Technical Principal Connected and Automated Vehicles with WSP. Frank also leads our technical working group, does a wonderful job with that. And last but not least, Dr. Henry Liu, who's the Professor and Director at Mcity, University of Michigan. I'll give a few minutes maybe for each of the panelists to introduce themselves and what you're doing. Suzanne, let's start with you.
Yeah, thank you so much for inviting me to be here this morning and to be on this panel. In addition to talking about the work that I've been involved in for a little over a decade now with testing, I'm also here representing Justin Anderson, who runs the ITS Joint Program Office's V2X, or Next Gen Wireless Test Program. He sends his apologies that he can't be here today, so I'm going to talk a lot about his program and what's going on within that program. I think from the USDOT perspective, there's really two aspects of testing that we're really interested in. New technology testing, and because of the fact that technology is so tied to communications these days, spectrum testing is a very close follow-on to all of that. When it comes to new technologies, it's really taking a look at what's emerging on the marketplace to ask what's the likely rate of adoption and could this technology provide any kind of public benefit. From a transportation perspective, that's the safety, mobility, environmental, accessibility types of benefits that we seek. And the question always is, how does this technology work from a safe and effective perspective? So we decide to employ this in transportation, what are we getting ourselves as well as all of our citizens engaged in, and how do we think we're going to get that benefit? And so obviously V2X was one of those technologies that came along that needed this kind of testing, and importantly, needed to understand how does the technology use the spectrum? How do the devices perform within that spectrum, and how do the devices come together to form these ad hoc networks that actually provide this public benefit? So the devices can help alert people to the threats and the hazards that are happening in the roadway, or potentially better mobility opportunities, or, you know, in some respects be able to work with the vehicle to help provide less environmental degradation. And I think we did a great job with a lot of that testing. As the first panel pointed out, we had a pretty significant shift around 2019 to go from what we had been working with, which is a Wi-Fi derivative of this technology, to cellular. So big questions needed to be asked. How does a cellular technology that tends to want to first schedule use of the spectrum and then operate actually do direct device-to-device communications, form these ad hoc networks, and perform the way we were all used to DSRC performing? So between 2019 and 2022, a lot of this program's focus was on that particular technology. Where were we at? What did it need to actually get into, you know, production type use? How did it perform? And we presented a lot of those results at that 2022 conference that John Quant was talking about. Those are online, should anybody want to see those results. But we did a pretty quick shift to interference testing at that point, noting that the technology did perform the way we expected it to. And so the question was, how does it work within the spectrum? And can our band be protected, given that we're now sandwiched between the unlicensed spectrum below and above? And again, it's Wi-Fi. So we don't have the listen before talk capability to help us understand interference coming in and deal with it. So what are we going to do here in this 30 megahertz from a protection perspective? And so since 2022, a lot of that has been our focus. We are beginning to release those results. You saw some of that in the presentation yesterday. We actually filed a technical memo on the 6 gigahertz docket about what we were seeing last fall from our test results. FCC conversation asked some additional questions, and we went back into testing. We have those results. They were in the slides yesterday. We are now updating that technical memo so if anyone wants to know more of the details, it should be up there shortly. So this has really been the perspective for a while, and the results are really, the testing is really done to inform FCC. I think the device testing has really been in sync with what OmniAir has been working on in terms of its test procedures. So the question is, well, where do you go after that? Say we get a second report and order in John's time period, 3 months, which is very aggressive, so I'm definitely on the over, John, wherever you are. Okay, we can talk about that later. So the question is, once the second report and order comes out, where does this program go? And there are a lot of different opportunities that have emerged in the past couple of years to be looking into. So this program is really, I think, going to focus to the 5G concept. So you're going to introduce 5G, and it's not compatible with the LTE V2X 4G devices we have in the spectrum. What do you do with that? What changes with the 5G new radio? Not just, you know, the fact that we need a different radio to operate, but different choices have been made about carrier sensing and modulation and how HARC is employed and things like that. So are you, the manufacturing industry, what options are you going to pick up on that? How do you think you want to employ the 5G new radio within this ad hoc kind of environment? And of course, very tightly tied to that is, the spectrum. Where are you going to operate in the spectrum? Where can we operate in the spectrum? What spectrum is not just available, but gives us the characteristics we need to perform the V2X communications that we're so interested in. I think another area of interest is that the telecoms have really stepped up to say, well, we have licensed spectrum and we think we can perform a lot of V2X. Maybe not the crash avoidance, and we admit we're not interoperable with one another, but there are hacks, there are band-aids, there are pathways that we can establish to get more V2X out there. And so we are starting to work with different telecoms. We've been in conversation with Verizon, AT&T, and T-Mobile. We know that some IOOs are setting up what they call the multi-edge computing MEC capability. And so we're being invited to come and take a look at how that's working and to fundamentally understand what happens with V2X on licensed spectrum as it's broadcast out to everybody else. How do we pick these messages up? There's always the opportunity to continue to use V2X in unlicensed spectrum. So that's going to be thought out and really kind of take a look at how that might actually come into being in some respect as well. And then, of course, there's the question of how do we get additional spectrum for this whole thing? With additional spectrum, one has to go modify devices and go test. So there's a lot to look forward to from this testing perspective, and it's very tightly tied to the standards work, which translate into the OmniAir test procedures work, which translate in the ability to get security credentials. And so I feel like this is the right technical community to have these discussions because it's also combined together. So thanks for that opportunity to give you that preview.
Great, great. Thank you, Suzanne. Monica?
Good morning, ladies and gentlemen. My name is Monica from Saesol Tech. My background is overall almost 20 years about some camera module side for the connected vehicle for LiDAR and also for the mobile. So working with great players in USA and EU nations previously. And then the Saesol Tech, I'm a global business development leader. And we are OmniAir cybersecurity sub-working group leader. And then we was a co-leader about development for 764B test cases for IEEE 1609.2.1. Since my last visit to this beautiful Ann Arbor, after attending the V2X Summit in last October, I think there was significant progress about this V2X industry in perspective, workforce and technology, and many policies and all efforts. So congratulations to all about this room people here. So today we are providing about SCMS and then cybersecurity certificates from the company. So I'd like to share about as an industrial perspective, how we make more secure V2X communication and also the preparations about this challenging based on the two opinions. Thank you.
Thanks, Monica. Frank?
Yeah, thanks, Mike. Good morning, everybody, and thanks for having me up here today, Mike, and for OmniAir for having us, having WSP here in general. So it's good to see everybody. You know, I'm part embarrassed to say that I've been doing connected vehicle deployment, design, testing, integration for 20 years. So 2024 is 20 years I've been in this business. And I say I'm embarrassed because, you know, back in 2006, 2007, when the USDOT stood up their proof of concept system about 30 or so miles east of here, that was with the intent of testing the technology and getting ready for a 2008 mandate that the technology would be in vehicles starting at, you know, some couple of years after that, you know, 2011 or whatever. So been around a while. You know, I'll say I know where some of the bodies are buried because I buried some, honestly. But, you know, so quick question. How many people remember the proof of concept system? So I know, okay. Yeah, and Dimitri, yes. Okay, so actually there's a few more than I thought. So that's good. We've all been here, obviously a long time, and we're continuing to push things forward. WSP and myself, we were also part of the safety pilot model deployment here in Ann Arbor. And honestly, I think that, and that was 2011, as Debbie Bazzina said this morning. I think that was the first time that we did multi-device manufacturer interoperability testing. First time that was done was for the safety pilot model deployment. Because back in 2007 when we did the proof of concept, that was kind of one RSU vendor and a handful of OBU vendors, which are now, I think, non-existent. But yeah, so and then we just continued to do these interoperability testing as in individual deployments, and then OmniAir came along, and now OmniAir is in the business of testing the devices, and not only for standards compliance but also for interoperability to take some of that burden off of the deploying agency, right? So that's what OmniAir is all about. WSP in general, so we have a couple of projects with the Connected Vehicle Pooled Fund Study. One in particular is we are testing SPAT-MAP and to a certain extent RTCM at 3 state deployments for compliance with CTI, or Connected Transportation Interoperability 4501, right? So, it started at ITE, and then SAE took it over, is in the process of, doing another release here in a few months. But basically that takes 2735 and other standards and says, okay, so here's the standards, but here's how you implement the standards, and here's what a SPAT message should look like, here's what a MAP message should look like. So WSP, again, is out in 3 states. We're testing deployments and for compliance to 4501. And honestly, it's mixed. I mean, there are a lot of things that are going right. There are things that could be, I say right, but I mean, it's to say in compliance with 4501. And there's things that need some tweaking, but then there's also things that the industry just cannot support right now, right? Like assured green period. There is no, because that relies heavily on traffic signal controller and other things that the industry isn't ready yet. So, so part of our job is to identify what the industry should be able to meet, what it could meet with a few tweaks, and then what is kind of later down the road once, some of the other devices, provide some upgrades. And then, again, we're still in the design, deployment, integration, and testing phase for several other deployments across the U.S. So, from an OmniAir perspective, as Mike mentioned, I chair the technical working group, which really the Plug Fest, the technical logistics for the Plug Fest is an offshoot of that group. So I've been involved in getting the track ready for testing and demos this week. Also on the board of directors for OmniAir, and so I've been at OmniAir since 2018, board of directors since 2018. So again, helping moving the process forward, moving things forward, taking all of my the lessons learned we had back from 2007, even still bringing those forward, and then building on everything we've done in between. So I think that's what I got.
That's awesome. Thanks, Frank. And I remember some of those events leading up to Safety Pilot and some of the testing and being part of that with you. And such an amazing job you did coordinating that. And maybe we get enough drinks in this later, we'll look for some bodies together. So, last but not least, let's go to Henry. Go ahead, Henry.
Good morning, everyone. Welcome to University of Michigan and UMTRI and Mcity. And Mcity as our organization is a public-private partnership, and it's no better event than this, that we will see government agencies, academia, and industry members coming together for V2X technology. And also, I'm glad to see OmniAir Plug Fest come back to Mcity after 2022. It's a great event. So I'd like to talk a little bit related with test environment, particularly in both Mcity test facility as well as in the city of Ann Arbor. Jim and Debbie has mentioned that we're working on 2 projects right now. One is called Smart Intersection Project, instrumenting city of Ann Arbor with not only CV2X devices, but also roadside perception sensors. Those are being implemented right now in the city of Ann Arbor. And then this project will be expanded to 75 intersections. And as she mentioned, 75 is majority of the intersection. I would say at least half of the city of Ann Arbor traffic signals will be equipped with CV2X devices. And so that environment is building of that environment is ongoing. I also want to mention it's not only just not only just instrumenting, and we're also generating messages. And so some of the intersections has already equipped it with roadside perception sensors from the cameras, and then these cameras we developed the algorithms to do object detection tracking and then generate sensor data sharing messages. And so if you have a device right now and these messages are being broadcast right now at Mcity. So one of the intersections at Main and the Stadium, just right in front of the big house, that intersection is quite busy intersection, and that intersection has 2 cameras there. And we utilize these cameras to generate object list, and then we package those into sensor data sharing messages. And those messages are being sent to the roadside unit within the Mcity test track. And then, so if you have a device, OBU device, you should be able to receive it now at Mcity test track. So it's not. Obviously, that's it's an intersection in the city street, on the city street, but right now we're broadcasting the sensor data sharing messages at Mcity test track, and so and that it's ongoing right now. Suzanne also mentioned that the MNOs, the mobile network operators, they have a lot of interest on these more or less a soft safety type of applications related with the V2X messages, utilizing their license spectrum. And we also have a proposal under review with USDOT now, working with 3 MNOs, Verizon, AT&T, and also T-Mobile, to establish City of Ann Arbor as a test environment for that as well, utilizing their virtual RSU capability and through their license spectrum. And so those are project activities we are having at Mcity. One of the other thing I want to mention is with these roadside perception systems, not only we are doing object detection tracking and then generating object lists and generating messages. Those sensors are also detecting crash and near-miss event occurring at this intersection. So if you go on to Mcity webpage, data.um.city, there's a list of intersections there. If some of the intersection has these perception sensor connected already, and you should be able to see some of those in real time in action. We have not really completed that yet, but hopefully by the end of the year, at least for the Smart Intersection project, with these 21 intersections, we should be able to see all of those working. In terms of applications associated with these test environment, as part of the Smart Intersection project, we're testing out 3 different applications. One is cooperative driving automation, utilizing sensor data sharing messages, the SMAP messages, and also the map messages to see how this can help automated vehicles. And that's we're developing these applications right now. And there's also a green wave advisory application will be tested out as part of this project. And then the third application will be tested out is transit signal priority through CV2X. So those are the three applications will be tested within these two projects in the city of Ann Arbor. And I think this is environment we'd like to have this environment as a national reference site, and so that you can come to the city of Ann Arbor and then test out various applications, interoperability related with different devices, and also both of these projects involve significant partners from the OEMs, for GM, they all involved, and Toyota, they all part of this project, and so they will be able to test out some of their applications with this field environment as well. So with that, I will.
Thanks. Yeah, thank you, Henry. I think you all can see from the depth of the introductory remarks, just the amount of experience you have on stage here. So I hope you take advantage of that. Think about some questions that you have, and I'll come to you here in just a little bit. But maybe selfishly, I have a couple of questions to kind of think about our program, our work program going forward in OmniAir. And Henry, you had mentioned the applications as part of your test environment, and I'm maybe interested in kind of we'll start with Frank maybe, but I want to understand. In OmniAir, we're working to address application testing, and kind of what is that application testing? What's needed? Will that be enough for the OEMs and the end users? And then get other thoughts from others on application testing too.
Yeah, thanks, Mike. Yeah, I'm a huge proponent of application testing, of OmniAir doing application testing. But with the understanding, right, is we're not looking to, I'm going to say we're not looking to really certify application, but maybe validate functionality of the applications, right? Because we don't care what the HMI is, what the user interface is. We just want to see that if a device is put in certain situations, that it can provide an alert to the driver. That's all OmniAir is concerned with, because to me, that sets a basic level of functionality, right? So then the OEMs can work with their suppliers, and that our OmniAir have been through the OmniAir process and been through the application process. So the OEMs can say, okay, I know that this device meets a basic level of functionality, and then work with that supplier or their supplier community to kind of refine, tighten up the requirements maybe a little bit, provide their own custom human-machine interface to their drivers, because they know their customers, better than anybody else does. So, and also it gives the deploying agency a level of confidence that when they're putting OBUs in their cars or their vehicles, right, that they know that again, these applications have a basic level of functionality, that should be just kind of a given. I buy an OmniAir application validated device. I know the applications are going to provide a basic layer of functionality. The applications and the user interface, that's what everybody sees, right? I mean, OmniAir does a ton of work on standards compliance, right? Making sure that the broadcast rates are correct, that the 3GPP, devices implement the 3GPP specs correctly, and the message sets and all of that. But that's all behind the scenes, right? What the driver cares about, even with the deploying agency, what they really care about is that the application works. The application gives a driver an indication or warning without overwhelming them with false positives in that. But the applications are really what people are looking at. People see every day when they're driving. So that's why I think it's critical that we have some basic level of functionality validation through OmniAir. So,
thanks, Frank. Other thoughts from the panel?
I think USDOT is very appreciative of that kind of validation testing for a lot of the reasons that Frank said, but importantly, we're really interested in the base layer, the radio layer, and how things function. And application testing allows us to see if there's anything that needs to be tweaked or addressed in some respect, or if there's something in standards that needs to go addressed that we can help move along or accelerate in some respect to get everything working the way it needs to. And it really gives us a good sense about the safety element, because all it takes is one or two applications to go wrong and the whole adoption becomes a question, right? And so we really want to make sure that whatever gets out there initially, not just that it works, but it provides the benefit as opposed to any kind of negative benefit. And so the question is, how can we help to make sure all of this is good? But, I think through OmniAir, this industry has really taken on a lot of that. And it's just really great to be a part of it and to be able to see the kind of results coming out of this work.
Other thoughts?
So one of the important things we learned from our test environment and deployment of application is, I think it's how to establish the trust between vehicles and infrastructure becomes so important for us. And in order for us to engage OEMs, and it's important so that for them to be able to trust the messages we come from the infrastructure, that include all the messages we are talking about, the SPED map and BSM and sensor data sharing messages as well. However, that trust has different dimensions as well, right? So there's accuracy in terms of these objects, and there's latency, there's reliability with the whole infrastructure as well. And so, so this is a part that we learned from Smart Intersection project. In order for us to have some sort of killer app to engage OEMs, building the trust is a must. And that's, we're still in the process and still in the learning process, and how we can, have this from multi-dimension perspective to build this trust.
Suzanne?
And that just reminds me of a request I have of you, Frank, and all the rest of you, is when you do the application testing and validation, please include the security credentials so we make sure that they work properly in a lot of different ways, yeah.
Yeah, absolutely.
Yeah, and that's maybe a great segue to one of the other, kind of hot topics that's going on. And the previous panel touched a little bit about this, and I've heard each of you kind of mention something about not wanting things to go wrong, trust, importance of security credential, and maybe starting with Monica, I'd love to start to hear some thoughts on what are the challenges that we really have for creating a secure V2X environment, and how do we address those?
Thank you. Thank you for having me here with the great moderator in the panels today. So, as we delve into the realm of connected mobility, one of the most pressing concern we face is ensuring the security of V2X communication right now. The challenges of this front are numerous, but I think, as an industry perspective, so that we have more opportunities for innovative solutions here. For the first, we need to adapt and execute the nation scale of a V2X deployment with a common and consistent requirements. So it is most important to validate the nation, the range of the actual V2X service quality. We are currently relying on POC or deployment reserved for some use cases only right now. So when we have V2X is fully deployed, and actually we're executing about misbehavior detections in a real intersection or the road, if we have poor quality, that will be really critical issues and seriously. For example, how can we verify and communicate when a vehicle equipped with OVU with expired V2X certificates enters into another city or states from the current situation? The other examples, some vehicles may not be able to download the rest of the OVU certificates they have preloaded in a wireless environment, and they must rely on the RSUs for that. In this case, how do we ensure reliable operation in different road environment per each state. The next example is, what if certificate installations or test results are not confirmed or available from the OVU, and problems happen by that reason? Do we have backup solutions? Or be ready for the real V2X era? So to address these foreseeable issues, nationwide common deployment plans and certificate verification tests should be executed. Of course, we need prefer IEEE 1609.2.1 validation tools to be supported. It allows to IOO's operator to set various test vectors or parameters by themselves, closely similar to the real intersection, such as adjusting certificate validity period, for example, 1 year or 3 years, certificate overlapping period, or adding, removing root, CA, and authentication result per devices and per CPs in SMS. To increase efficiency and reduce about these fatalities, certificate verification and testing process should be automated to reduce about by operators' human error and run based on each test cases of all SMS profiles from current POC levels to expand national range. I think while V2X was more active this year, but the lack of the number of and entity device makers adopting IEEE 1690.2.1, even DOTs are targeting to adopting that certificate. It shows the real gap to actual deployment to V2X deployment in a near future. So second one is, let's talk about data integrity in mobility and connected vehicle era. Here is for example, when drivers use their smartphone during driving, they will get multiple information and data from various apps via Android Auto or CarPlay. In this case, between these car compatibility apps and V2X OVUs will transmit vehicle and RCU data to each other, as well as traffic information from the network. What if a malicious attacker gained access to the driver's V2X network to determine the identity of the recipients of communications, or verifying information, or this data is easily exposed to the outside world? It means we need to adapt in a short period of V2X with robust encryption techniques for each authentication and certification installation, some process from end entity to authorities, to ensure that sensitive personal information to be secured and remain as confidential. So based on these two main challenges, how do we address about these challenges? I think, and everybody I think agree about this is not a simple task, but we can get through it by a multifaceted approach. First, we can collaborate and share feedback about V2X policy, test cases, and use case creation between industry stakeholders and specialized consortium like OmniAir. Then, nationwide V2X security deployments and getting feedback from the public sector, IOOs, by investing and adopting robust VDWAC security protocols in the near future, fostering collaboration by government among stakeholders, we can, I think, unlock the full potential of VDWAC security communication while keeping about to load safe and then also secure for all. Thank you so much.
Thanks, Monica. Other thoughts from the panel on security? What keeps you up at night?
So from a from integration standpoint, it really goes back to the trust, but then the authorization of a device to be able to request things, specifically for transit signal priority or emergency vehicle preemption. Right, we want to make sure that the devices that are requesting changing timing on the controllers are authorized to do that, right? We don't want anybody to be able to drive down and say, oh, I can cobble together SRM and broadcast it. No, look, I get priority or preemption, right? So, that's, security is a huge piece of that, making sure that, the devices that are sending the requests are who they say they are. So if they're a transit vehicle, need a mechanism to validate that they're a transit vehicle. If they're an emergency vehicle, got to validate that they're an emergency vehicle. And not only that, but that they are authorized to make that request, right? So you can't have a transit bus from Ann Arbor driving into Detroit and getting signal priority. I mean, maybe you do, but maybe you don't. So we want that level of control. And then on the first responder side, emergency vehicle side, there's public ambulances versus private ambulances, and do we want those two entities to have the same level of authority? So it's things like that need to be figured out, and the IOs have to figure out how they want to handle those types of situations. So, and again, that all comes from security, from the certificates, and then to the service-specific provisions that provide that authorization. So,
Thanks, Frank. Other thoughts?
Yeah, I think what keeps me up at night is the network aspect of what we're moving towards these days, the IoT concept. I want to amplify what Debbie said on the first panel, that I think we did a really good job of building security and privacy in from the beginning. And that's very detailed. As Frank was just pointing out, the notion that you've got to consider the type and level of security with each message and each different type of installation. And as Monica said, we've got this really great opportunity with our own security credential system, which means that we're our own little IoT, and you get to play if you're trusted and authenticated or authenticatable, but don't come knocking on our door otherwise. But there's this real push to bring in all sorts of other data and interest by the telecoms who do not use our form of security, won't really talk about the form of security that they employ. There's the whole aspect of the Wi-Fi access points and the different ISPs there. And so you're suddenly finding that we're in this world of far more opportunity to come into our world. Now, what was nice beforehand was that, and I'm not sure if folks are cognizant of this, but before, when we had the proof of concept system and moving towards actual deployment, we actually did a lot of testing to try to hack into the system, try to hack into a V2X type of environment, so we could see where the vulnerabilities were, where the warts were. I think one of the nice things is that you could look at it as a very localized problem if a hacker actually got in, because then misbehavior detection would take over and start to recognize when messages were bad, and we could start to shut things down or not recognize those messages. But again, as we move to this hyper-connected world, that doesn't apply anymore. And so one of the things I will mention for folks is that the National Institute of Standards and Technology, or NIST, has come out with the cybersecurity framework. It's actually a really good practice exercise to go through. It basically makes you state your business mission or your operations mission right up front. What do I have to do to make sure that things keep going on? And then what are my priorities in terms of security? And as you work through this, it produces a whole list of standards and controls and other things that you can and should be implementing. And so we've tailored that for a V2X environment and now an ITS environment. And we're really working with the deploying agencies to please adopt this, please go through this exercise and understand it. I made myself a note. I don't know if a vehicle cybersecurity framework has been done yet, but I think it's probably worth looking into. But yeah, what keeps me up is that as we all come at this from a different perspective, we're all combining ourselves into this trusted ad hoc communications environment, and what else is filtering in. So, thanks.
Okay, I wanted to leave a little bit of time for some audience questions. Anyone have anything burning you'd like to ask this panel? Such a talented panel. I have some more, but I wanted to give the audience some chance. Okay, well, keep thinking. One of the things that the previous panel had talked about was standards, mandatory versus voluntary, and I thought that was a good discussion. And one of the things as we think about V2X testing is this is actually where we get to really test the standards, see where there are gaps, see where there are ambiguities. Any thoughts that you all have? Maybe start with Suzanne, since you're so close from the spectrum testing and everything too about standards. What are the gaps in standards, and what do we need to do in that area?
That's a really good question. That's an analysis that I think still needs to be done. I've worked in this world for so long that I really think standards are the keys to the kingdom, is what I like to say. They really kind of tell you what needs to happen and how it needs to happen. I think actually one gap I will discuss with you, and we're getting better at this, is how do you implement a standard? Can a guidance document come along with it? Can a proof of concept come along, or a reference demonstration come along to show people this is what you do, and the necessary tools to be able to do this as well? The IOOs are in a really interesting position. You know, they used to be really good at just putting out roadways and maintaining signs and traffic signals and everything else. And we're now asking them to get into a world of computer science, engineering, coding, spectrum engineering, that they haven't been there before. And I've been seeing different state and local agencies go out for new kinds of engineers. But the engineers come on board, they need the actual knowledge and the tools. So hopefully one of the things that we've done positively is actually open up the standards to this environment for free. They're available through ITE and SAE and the ISO standards to be able to go and grab and actually implement. And we have technical assistance teams to help with interpretations. We're getting better at doing more proof of concepts to show people how this works. Even having like these roundtables where we bring people together and say, show me your interpretation of this standard, show me your interpretation, and let's see if this works together. But I do admit that as we get past the second report and order, which are going to be the rules, ideally in sync with all the standards we have, we then start to have to think about, so what other things do we need to put in place? And to go back to the other panel, not everything has to be a standard. Standards are, in my mind, somewhat of a proactive approach because you recognize where you could have problems and try to resolve them. I think industry folks working together is a really great idea, but sometimes we have to find our problems once we've implemented and then backtrack to go fix. But then that usually shows us where standards are needed, right? So it's a bit of a back and forth, pro and con, in terms of which direction you go. I'll throw one more idea in, and that is that we've had a very interesting opportunity to start with working groups that create sort of these looser specifications. Not quite as detailed, but we know we need something. So the work zone data exchange is a really great concept where we took a look at what they had produced and what we're actually implementing and saying, hey, that's work. That really works and it's great and it's gonna be adopted by others. Let's standardize the core. So we took a certain amount of that and went into standardization with a lot of these folks. In the meantime, a lot of these folks are taking what's left and I guess you could say forking it, right? They're taking it in all sorts of new directions that we're not quite sure where it's going to go, but can inform the current standard underway or can inform future versions of that standard where we add to it, you know, not change it, but add to it and keep growing. So I think we'll see a lot of that going forward. And certainly if any of you have ideas where standards gaps exist, would love to hear it. Thanks.
That's great. Thanks, Suzanne. Other thoughts on standards?
Regarding standards, as I working as an industrial perspective, we need to understanding more exactly between using about standards in public sector and private sector, because the use case and then also the working environments, I think, totally different. But all test cases, the mandatory from OmniAir. So, but I think some of industrial sector does not understanding or does not well recognize about that. So how we can prepare about common targets or common perspective about that standard to in a same page to starting about that standard or deployment plan. Because for example, some of OEMs, they are acting as not only for the OEM, they just are working as acting as a service provider together. They have their own mass production line, and also they have their own schematic for preparation, maybe FreeDOX preparation for later on. But we do not have some specific information or how we can prepare about that standard gap between the two public and private sectors at all. And also, secondly, the legacy about the Camp Wiki standard will really need to be supported some period together when we adopt about IEEE 1609.2.1. So in this case, we need to use for some period as a parallel. Then how we can support about two standards altogether in a real road or intersection. That is one of the things some customers are questioning to us for the certification preparation. So real world is a little bit different than we expected.
Thanks, Monica. Henry?
Mike, you mentioned the gaps in standard. I want to echo some of the words Suzanne would mention that it's not only just the standard, but also really how to generate these values within the standard. For example, last year, the sensor data sharing messages, the SDSM was released in terms of the standard, but there's also requests. There's also the field that you need to fill in that in terms of the variance related with the object location and also speed and things like that. It turns out it's not as easy to even to estimate the variance out of the algorithm we developed, and so how you it's not only just a standard, but also how do you generate these values within the standard fields, and then so that people know how to generate the messages according to your standard. So there's certainly gaps there within some of these standards that were small research. It's not only just releasing the standard, follow the standard, but also how you really generate the values in the reliable and accurate manner.
That's great. Okay.
Guess,
go ahead, Frank.
Yeah, Mike. So
go ahead.
I know this isn't the intent of your question, but from a gap perspective, I think there's a gap between the published version of the standards and what devices support, and that's a natural gap, right? Because the device manufacturers are part of the standards process, so yeah, they have a leg up on what's coming, but there's still development time for when these new standards come out until devices can support them 100%, right? So we have to recognize that, and I think a lot of times we get caught up in the fact that, well, there's a new standard was published today. I got to implement it. I got to, have it out on the street tomorrow, right? And that's just not realistic. The other thing too is, the standards are always evolving for good reason. But then, a new publication may not be backwards compatible with devices that are on the street today, right? So there's a challenge there. So, from a gap perspective, again, I think there's a gap between what is published, what's available in the devices, and then, how do we upgrade devices to meet the new standards if it can be done, simply through a firmware or software update. So, again, going back to Suzanne's comments and the panel before us, I believe standards are necessary, but again, I think that they can also be holding us up a little bit. So we need that balance of, we need a baseline, and that's the standards, and then we need to go out and implement it, and maybe come up with a implementation guide or or a convention guide on how to use it. As I was getting ready for this panel, I was talking, going in my head about, what stories could I tell about testing? I got a lot, but I won't. I'll just focus on one, which was really, I'm gonna say, an eye opener for me. I mean, I knew in my head, that there's the standard, there's the words on the paper, and then there's the interpretation of those standards. But that actually came to life during safety pilot model deployment, where we had the basic safety message, where we had 2 device manufacturers implemented the basic safety message according to 2735. But they were not interoperable, right? And we looked at the interpretation, or we looked at 2735, the words were on the paper. We talked with both device suppliers on their interpretation of it, and both interpretations were correct. If reading the document, both interpretations were correct, but they were not interoperable, right? So that's,
Great thoughts.
Yeah, I agree with Frank's idea. So as an industry perspective, we also felt about the big gap, about the preparation about the devices with a new standard perspective. So if USDOT considering about this 16609-1 certificate for the next era, but still OVU or this device makers are not that pretty much adapt about this security stack for this new standard between the devices. So I would like to suggest about this great opportunity about this plug fast via OmniAir. So industrial or this device or equipment maker using about this standard and the interoperability test will be more increased, then this will be more promoted to this new standard as deployment or preparation, and then the new era is ready.
Great, thank you. Well, I see we're down to just the last couple of minutes, so I'll probably just take an opportunity. I want to keep us on time. I know we've got a lot of things to do today, but I really just want to thank this panel. Thank you all for sharing your thoughts on V2X testing, the application testing, the security, the standards. I thought it was wonderful. I hope you all got a lot out of this, and I hope you all take advantage of having this panel here today and talk with them during the break and chat them up and get their thoughts on things. So with that, we'll conclude, and please help me give a round of applause to this wonderful panel. Thank you.
Thank you.
Yeah, thanks, Mike.
you.
Thanks, everybody.
Well, that was a great discussion. I think you can see the breadth and the depth of testing that is necessary to make this world of connected vehicles a reality. So thank you to Mike, and thank you to all the panelists for just a really, really excellent presentation. So before lunch, we do have a keynote speaker, but I do want to recognize some of the volunteer OmniAir leaders here in the room. If you are a chair of an OmniAir working group or sub-working group, or if you serve on the OmniAir board of directors, just ask you to stand up. Don't be shy. So you can look across this room. You can see each of these individuals. If you have questions about OmniAir, you're thinking about getting involved, you'd like to contribute to the working groups, you'd like to think about a leadership position, I would encourage you to speak to one of these individuals. And they'd be more than happy to put you to work and get you involved. Thank you very much, gentlemen. You can all sit down. Ladies and gentlemen, of course. So I would like to introduce our first keynote speaker. This will be the last speaker before lunch. You will be well fed. I know that you might be able to smell the great food wafting in the air, but try to pay attention because we have a powerhouse speaker here. Dr. Bogdan Epureanu is the Roger McCarthy Professor of Mechanical Engineering and the Arthur Thoreau Professor in the Department of Mechanical Engineering at the University of Michigan. He also is the director of the Automotive Research Center, which is an U.S. Army Center of Excellence for autonomous vehicle testing, among other things, ensuring that America's warfighters and those of our allies have access to the latest and greatest autonomous vehicle technologies. In addition to that, he is here to speak about what I think is a very exciting initiative, Mobility at Michigan. One thing that I've discovered is probably a secret to why Michigan is a leader in this mobility revolution around the world is there are so many different research institutions and other academic institutions all pushing forward on various initiatives. And this initiative he's going to talk about is pulling those resources together and ensuring that we have collaboration to help move America forward. So I'm very, very excited to hear what Dr. Epureanu has to say and to get his insights on where we're headed in this industry. So without further ado, the floor is yours, sir.
Thank you very much for the introduction. To all of you, I would like to extend or echo Jim's welcome to this workshop and to the University of Michigan and the state of Michigan, where, of course, we all know the affordable automobile was born more than a century ago. What I would like to discuss today is the future of mobility and the importance of collaboration. I think we all agree that mobility it's extremely important, and we all understand that collaboration is essential for progress in this area. So, given the work that you all do and the fact that we are here at the OmniAir Plugfest, I know that, or I hope that this will resonate with you because you have an interest in advancing the interoperability of technologies. So in that context, we all know the foundational role that mobility plays in today's world. It drives a thriving society. It underpins individual quality of life. It is essential for a strong economy and also extremely important for a secure nation. So, but we are at a turning point in this area, and I would argue that this turning point is as important as the dawn of the personal vehicle and mobility itself. So we live in a time of unprecedented opportunities, but also urgent challenges. And so what I would like to do next is I would like to discuss some of these opportunities, highlight a few of the challenges, and then express how the University of Michigan is coming together, is putting together all our resources to seize these opportunities to address these challenges. So let me start with opportunities. One of the very important factors that is occurring today is the fact that technological development is accelerating, is at the faster that it's ever been, in particular in the area of transportation, into area of mobility. And that opens a lot of new doors, a lot of new solutions. But these solutions are also very multifaceted. So there are new solutions that need to address these very multifaceted demands. In particular, these new transportation patterns are occurring, as well as new consumer behaviors. And this makes the application of the new technologies as solutions particularly important at this moment in time. In related to that, perhaps, is another opportunity, which is the fact that these advanced technologies, including, for example, the ubiquitous use of autonomous technologies for mobility, is opening doors and assisting areas where there are workforce shortages. This includes a number of areas, but perhaps we don't think of agriculture, forestry, or ecosystem management as the first ones, but they are included in these opportunistic or these opportunities. But of course, all these opportunities are also presenting a number of challenges. In particular, there are substantial global and individual threats that as we develop these technologies, we have to be mindful of and address them in an integrative approach. And I'm listing just a few here, but injuries and death, for example, on US roadways remains high. There is an unprecedented income inequality and other disparities that are influenced in a profound way by mobility technologies. And I'm talking about both the manufacturing of mobility solutions as well as the deployment and the use of the various mobility solutions. Also, there is a large, well, the mobility represents the largest single source of US carbon emissions, which of course presents significant challenges in society and must be addressed. And from a sort of national security standpoint, mobility is extremely important in addressing geopolitical issues that threaten national security. And it's not just about security, but it threatens things like supply chains and other things that are affecting our economy. So to seize these opportunities and to address these challenges, 5 of the Michigan engineering leading mobility organizations have launched what we call Mobility at Michigan. So we are not a news center. You can think of us more of a collaborative initiative. But before I present what our vision and our goals are for this initiative, I would like to give you a brief overview of the entities, of these 5 entities that came together, and discuss briefly what we focus on in these entities. So first, I would like to discuss very briefly, the Automotive Research Center. Or the ARC, as we call it, which I direct. We are a multitude of partners in the ARC that span government, academia, as well as industry. Our focus is on developing modeling and simulation technologies for ground systems with a particular emphasis on autonomy. So use of autonomous off-road vehicles, use of or teaming between autonomous vehicles and humans, human-machine integrated formations, and these kind of applications. We are developing modeling simulation coupled with verification, validation, testing. And so we do this for military, but we also have a dual use perspective. And so our industry partners, some of them are defense contractors, but many of them are not, because both industry and government actually have the same pains. They are trying to solve very similar problems. So coming together in the Automotive Research Center, we deploy our academic resources and research talent to address them. And one of the important things that is happening in the center, which echoes what Mobility in Michigan is overall, is the fact that we understand that there are certain silos around these groups of stakeholders. So we are breaking down these silos. We are bringing together different expertise and different stakeholders to address these problems. And why we do this is because these problems are very multifaceted, very multidisciplinary. They require a convergent approach where the problem, the solution is developed by multiple experts from very different disciplines and very different parts of the society to address them holistically. And so that's why we have not just engineers, but we also work with computer scientists. We work with human factors, School of Information, a number of disciplines, psychology, and so forth in the Automotive Research Center. So these are activities that highlight our sort of approach to bringing together, to creating this partnership within the Automotive Research Center. Another of the 5 units that I mentioned that came together in Mobility at Michigan is our Electric Vehicle Center, or EV Center, which is the newest mobility-related unit on campus. It was just launched last year with a generous amount of support from the state of Michigan. And it has the goal of maintaining our historic leadership in the automotive technologies. The center is working to accelerate EV technologies and to also create education and workforce development, as well as lab infrastructure that are needed to support both the education, workforce development, and research activities. In addition to this, the EV Center is the home of the Battery Lab, which you probably or might have heard of, which has opened back in 2015, and it was the nation's first university-based pilot line. Today is the only one located in the heart of the auto industry, and the good news is that there are plans underway to expand it. Now, of course, you all know Mcity, so you all know the excellent activities that are occurring there, and of course, you are performing tests there over this week. But of course, you also know that it was created more than a decade ago. It is a public-private research partnership that brings together a diverse expertise and resources, in some sense similar to the ARC, that are required to realize the potential of emerging mobility technologies, with particular focus, I would say, on autonomous systems. Of course, today's Michigan Mcity's community of members and partners represents a very deep bench of industry, academic researchers, startups, government, nonprofit organizations that are all focused on advancing transportation. And of course, the Mcity test facility, where the Plugfest is being held this week, underpins the Mcity's evolution in this in a maker space for mobility innovation and for experiential learning for our students. Another of the 5 units is UMTRI, the University of Michigan Transportation Research Institute. You are all very familiar with UMTRI. It was funded back in 1965, and it has been a national and world leader in crash analysis, in driving data analysis, in analysis and research on driver behaviors, in injury biomechanics, ergonomics, a variety of areas, occupant restraint systems, as well as traffic modeling. It's probably, it is one of the industry's largest and highest quality, it has developed one of the industry's largest and highest quality naturalistic driving data set, and is the world's largest set of connected, it created the world's largest set of connected vehicle data. So in itself, all these organizations that I'm describing are very, very strong. The last one that I would like to discuss, the 5th one, is actually the oldest that we have on campus, is the Lay Automotive Lab. The lab was housed in, or is housed in, our Department of Mechanical Engineering, where I'm also a professor, and is the oldest transportation-related unit on campus. In fact, it was basically a wood shack or a wood construction back in the early 1900s that was adjacent to the engineering laboratory that was at the time. Of course, since then, many things have changed. Today, it hosts 19 specialized test cells where researchers investigate a variety of transportation-related issues, including engines, engine efficiencies, hybrid powertrains, low-carbon fuels, battery diagnostic, characterization, and emissions, as well as autonomous technologies. So, as we've observed as the propulsion technologies have evolved over time, so has the Autolab in its current and it's currently under renovation to add capabilities to for research and education, workforce development related to electric vehicles, grid technologies, building and micromobility applications, as well as autonomous off-road autonomous technologies. So as you can see, we now have an overview of the breadth of mobility landscape at Michigan Engineering. And so over the course of the past maybe a year or less, we've been working more closely together, these 5 units, because we recognize the important collaboration at this particular moment in time and the need for convergence to address these very complex challenges in the mobility industry. So I would like to share with you next our vision for reimagining the future of transportation. So in particular, our vision is to advance mobility for continued U.S. leadership and a future that is safe, a future that is equitable, a future that is sustainable, and a future that is secure. Therefore, addressing some of the challenges that I highlighted, such as injuries and death, societal disparities, climate change, or geopolitical instability. So in order to address this, we are building upon a very strong foundation. I highlighted some of the contributions and impact of this organization or focus of these organizations that came together, but I would like to highlight that this is just the tip of the iceberg at the University of Michigan. Over the past 5 years, there were over $600 million in research expenditures related to transportation. There are over 120 faculty that perform research in mobility and transportation research, and there were, over the past 10 years, there are more than 20 startups in this domain. In particular, the activity in startups and the activity of deploying and creating new technologies is a reflection of the fast pace of technological development that we need to respond to. So to respond to this, to achieve our vision, we established a few goals. And I'd like to highlight with you the 3 most important goals that we have. The first is essentially the fact that to realize a whole that is bigger than some of the components of all our activities in education, workforce development, research at the university, and entrepreneurial activities at the University of Michigan. So we want to facilitate a broad-based and integrated approach that address these challenges of creating safety, equity, sustainability, and security. That goal is related to the need, or is synergistic with the need and our goal of strengthening ecosystem innovation. These problems that we are trying to address are very multifaceted and very complicated. Therefore, we need to break down silos around the various disciplines and various organizations that are addressing them to see mobility and to approach mobility as a whole system that integrates research, it integrates workforce development, education, as well as public engagement. So we see these first 2 goals as synergistic and also related to our third goal. And the third goal is what we call thoughtful advancement. But really what this means is that we're trying to make sure to be mindful as we create solutions and deploy new technologies in a way that we do not create other problems, right? So it's very easy to deploy technology and then discover later some unintended consequences. So therefore, thoughtful advancement of technologies is very important in bringing together a variety of aspects that includes autonomy, electrification, low carbon fuels, connectivity, as well as modeling and simulation for technological development. So this last goal is part of our initiative to facilitate strategic discussions around all these areas in a holistic fashion. The ecosystem of innovation, we are planning to hold workshops and other activities to strengthen our understanding of all the other stakeholders in this complex field of mobility seen generally. And also our integrative approach, we want to have activities to demonstrate all technological advancements in each of these units in integration projects where we will bring advancements from each of the 5 units, for example, into one big project that demonstrates how the whole is bigger than the sum of the components. So this collaboration across academia, industry, and government are the only way to, we are going to be able to harness these opportunities to address the challenges that I faced. Very significant challenges, very large scope. I've seen this, and as I noted before, firsthand in the Automotive Research Center. So now I would like to take a few moments to celebrate some of the successes that have resulted from this type of collaboration in the recent years in the 5 units, and some of the 5 units that I discussed. I hope this will convince you, if you're not already convinced, of the fact that partnerships are extremely important for achieving these important goals and achieving this holistic perspective on the mobility of the future. So let me start with UMTRI and the safety pilot model development, which is, of course, we wouldn't be here today if not for the U.S. Department of Transportation's vision. Back in 2012, so it's been quite a few years, they partnered with UMTRI to launch the safety pilot model development, aimed to address the effectiveness of connected vehicle technologies in reducing crashes. The effort found that, yes, connectivity can reduce unimpaired crashes significantly. And today, we are seeing, of course, automakers make active safety features standard. And these active safety features are needed and are used also in a variety of other applications, including in military applications. For example, extreme maneuvers are very much related technologies. Then the active safety pilot has evolved into the Ann Arbor Connected Environment, which is still used today for research and testing. It is the world's largest operational real-world deployment of connected vehicle and connected infrastructure technology. So this is one of the important elements that occurred at UMTRI. Mcity, pursuing living lab and testing capabilities. They, for example, they led the driverless shuttle, the Mcity's driverless shuttle, which became the nation's first autonomous vehicle shuttle research project. Focused on user behavior. It led to partnerships with May Mobility, also U of M startup on trial developments in Ann Arbor and in Detroit. So this was complemented by technologies developed and deployed to enable remote use of Mcity testing resources with National Science Foundation support. Going back to the ARC, to the Automotive Research Center, I'd like to highlight a few contributions that occurred because of the partnerships between industry, academia, and government in areas like standards, like creation of startups or technology transfer. For example, with partners from the Army Futures Command and the Ground Vehicle Systems Center, as well as over 30 companies, the ARC has led the development development of the NATO mobility standard, which is a standard used to characterize mobility of off-road vehicles by all NATO countries. It also led to unparalleled development of unparalleled controls for off-road vehicles, especially autonomous off-road vehicles. The technologies that were transitioned from the ARC has been in existence for about 30 years. These technologies span from battery SOC estimation to virtual prototyping, anthropomorphic models, as well as many technologies related to powertrain and propulsion in the earlier days of the ARC. An example is reliability-based design optimization technology and later software that is the heart of a ARC or a company that spun off the ARC several years ago. Overall, and by the way, I'd like to take this opportunity to let you know that the Automotive Research Center will also have an annual meeting coming up in June where we will have discussions on things like standardization that the panel before were discussing, and it's about standardization of modeling and simulation technologies, particular modeling and simulation for ground vehicles for ground vehicles, yes. So in conclusion, I hope that you will agree with me that together we can join forces and we can realize this advanced mobility for continuing the U.S. leadership and future with a particular emphasis on safe, equitable, sustainable, and secure mobility for the future. If you are interested, we would like to ask for your help to bring this vision to life. In particular, I will like to ask you to explore options for joining us, joining forces with us, collaborating with us, sponsoring activities, or partnering with the University of Michigan mobility organizations and researchers. There is a contact email there, of course, if you are interested. I know you know some of the organizations like UMTRI and Mcity, but I encourage you to continue this engagement and help us realize this future. And so with that, I will stop here, and I would like to try to answer any questions you might have. Thank you. Yes.
Do you have any initial projects in mind to kick off the collaboration? Or are you just going to put an umbrella over existing efforts?
So what we want to do is, there are multiple facets to your question. Regarding projects specifically, we want to start these integrative efforts in which we were going to demonstrate technologies developed in all these units on a single platform, if you will, on a single in a single demonstration. The reason for doing that is because technologies that we develop in each of the units can synergize with the technologies developed in the other units, right? And so deploying them together will really highlight the entire impact of these technologies when put together. So we are going to have projects like that, yes. On a more or on a different perspective on that is we want to organize, we are planning to organize workshops to decide what are those, what are future directions for the University of Michigan. We're also planning in this area, we're also planning to organize technology showcases, but it's not a technology showcase where companies come and demonstrate what technologies they have, as they have, for example, in the DoD, but rather have a technology showcase where we showcase our technologies developed at the University of Michigan and find ways to partner with companies that are interested in pursuing doing that and adopting those technologies. One example of this is the Automotive Research Center. I'm very familiar with it, of course, because I lead it, but that happens in other organizations as well. In the ARC, for example, we have every project has squad members that are from industry, government, and academia, and we always look for how to transition these technologies. The IP, for example, belongs to the government, and they have royalty-free license to with the right to sub-license for government purposes. So we want to have a technology showcase like this in June to engage with companies that are interested in adopting our technologies and developing them further to a product that can go into that can serve the needs of the government. In addition to that, there are a number of projects that are industry-led. As I mentioned, the EV Center has a technology roadmap that is defined by industry. So there are different touch points between industry, government, and academia that we are planning to reinforce and demonstrate or explore how we can all benefit by working together. Any other questions? Yes.
Collaboration that you're talking about. I think collaboration seems to be the theme of today, cooperation, collaboration. And it's really heartening to see that happening in Michigan. Now, you mentioned partnerships with the private sector. There are a number of vendors and organizations here from around the world. What are the opportunities for the private sector collaboration with this new initiative? And maybe just start with that, especially for for those that are looking to site their R&D facilities in the U.S. I mean, why is Michigan a great place to think about that?
Oh, that's an excellent question. Thank you for asking this question. So there are multiple ways to engage, and different. All these 5 units have most of these ways. For example, I'll start with the one that is the lowest sort of barrier for engagement. In the Automotive Research Center, all projects have this quad structure. We have quad members, meaning I specifically identify stakeholders from government, from industry, from academia, like the professors leading the project, the students that are responsible day-to-day activities, the government quad member that is responsible for making sure that what we develop answers the government needs, and the industry quad member who is basically has a seat at the table as we develop the technology. That engagement costs no dollars. It basically costs only the time of the industry partner experts that are participating in our projects. So that is the lowest, the easiest, I would say, form of engagement. There are more profound engagements like in the EV Center. If the industry partners are interested in defining the research agenda, then becoming members of the EV Center is another pathway to engage and drive the research agenda rather than just witness it and influencing it. As it is in the ARC. Mcity also has a partnership model, an affiliates model, if you will, that also provides opportunities for industry partners to drive the agenda. In the ARC and in the EV Center, for example, the investments that we make are, the investments the industry makes are leveraged basically because the resources that we deploy are not financial resources from the industry partner all the time or not in the majority. So there are engagements that occur through, for example, use of our facilities for studying specific aspects that are common problems for the government and for the industrial partners. So there are multitude of ways to engage. One of the goals of mobility at Michigan is to clarify this ecosystem because it might be daunting. There are so many things happening in Michigan. If there's a company that says, I want to engage with Michigan Air Mobility, who do I talk to? Do I talk to this person? So that's why we created Mobility in Michigan. So it clarifies that pathway, it optimizes our interaction, it makes sure that we deliver the best we are the best kind of partner for our industry colleagues.
Thank you very much. Do we have any final question for Dr. Epureanu? Well, please join me in thanking him for an excellent presentation.
Thank you.